Overall, utilizing relations with distances in dots to specify search areas is simple and effective. However, you may encounter some limitations in real-world production scenarios. This becomes evident when documents are created from different sources. Here, dots may not work well anymore. Consider the following example. We have a grid that shows inches and dots per inch. Here is 1 inch. Now, for a 300 dpi image, 1 inch is equal to 300 dots. Let's say we have a rectangle, R1, with the following coordinates: 0, 0, the upper left corner, and 150, the bottom right corner, measured in dots, here. However, if the same document is scanned at 600 dpi resolution, the physical distances on the page remains consistent, but the sides of the rectangle defined as 0, 0, 150 dots becomes half the size of the corresponding rectangle sides in the 300 dpi scan. Having documents of different resolutions, perhaps from different scanners, or maybe from a scanner and a mobile device, demands our capture algorithms accommodate these size differences. We can confidently use relations measured in dots only when the scanning parameters are consistent, like always 300 dpi. But we can still use relations for documents of varying sizes by utilizing a very powerful technique. So, what is this technique? Let me add one more rectangle, R2, to my page simultaneously on both scales. We can now define the right boundary of the second rectangle, R2, in relation to the left boundary of the first rectangle, R1. In a 300 dpi image, this relation would be expressed as the left boundary of R2 equaling the right boundary of R1 plus 50 dots. In a 600 dpi image, this relation becomes the left boundary of R2 equals the right boundary of R1 plus 25 dots. We can see that everything is exactly 2 times smaller in the 600 dpi image compared to the 300 dpi image. The crucial point is that even with different absolute values, the relations between elements on the pages remains consistent. So I can say the width of R1 is twice the height of R1, which is true in both cases. We can therefore conclude that it's best to employ relative measurement units rather than dots. In our example, for the 300 dpi image, instead of expressing the relation as the left boundary of R2 equals the right boundary of R1 plus 50 dots, we can state that the left boundary of R2 equals the right boundary of R1 plus the height of R1. This statement remains equally accurate for the 600 dpi image. Now let's define the bottom boundary of R2 using the height of R1 as a measurement unit. On both documents, this would be the bottom boundary of R1 plus twice the height of R1. In production projects, we typically select either the height or width of a text string that can reliably be found on each and every document. This is important because we depend on this element to use this technique. Sometimes these strings are referred to as document identifiers. Now let's play a bit more with this concept. We have our document grid set to dots, as is the default in the Extraction Rules activity editor. However, considering the risk associated with dots, we should create relations using a relative measurement. At the top of the page, we've already detected the text element keyword invoice, and its height is 100 dots, which we'll use as a measurement unit. Now, we've found the keyword invoice no, and we want to locate the actual invoice number to the right of this keyword. First of all, for our convenience, let's declare a name for keyword invoiced height. We can use the following expression, let A equal keywordinvoice.rect.height. Now, we measure everything in A's instead of heights of the keyword invoice rectangle. The invoice number field is located on the same line, give or take, as the keyword invoice number. To indicate that the targeted element, the invoice number, aligns horizontally with its keyword, we use a combination of two relations, below the top of the keyword and above the bottom of the keyword. Since related text may be slightly shifted on different documents, we extend the search area slightly to ensure a proper match. To create the necessary relations, let's proceed as follows. Below keyword invoice number .rec.top minus a divided by 5, that is 1/5 of 100, to move the search area 20 dots higher. Above keyword invoice number .rec.bottom plus a divided by 5 to move the search area 20 dots lower. Similarly, when a related element appears below the keyword, we use the combination of two relations, left of right and right of left, with small offsets. For instance, right of keyword invoice no.rec.left minus a. In this case, again, a is 100 dots. And left of keyword invoice number.right plus a. In this example, we haven't altered the value of a. Depending on the situation, we can either scale the relative measurement value up or down, or not change it at all. That's it! Incorporating this concept into your projects will allow you to process documents that came from different sources and therefore are different sizes. This kind of power will be needed in many production scenarios, so it makes sense to become comfortable with this technique.